Welcome and thank you so much for joining me today. So we are going to be looking at walks, trails, paths, circuits and cycles. So a walk is any route through a graph, so a sequence of edges connecting vertices. And it doesn't matter if we overlap. And that's why in our graph we can see that we are overlapping. So when we are stating our walk, we just list the vertices that we are traveling from and through. So we are starting off at G, at G1. Then we are traveling to B. Then we are traveling to F, going to G2, and through to the old tree, which is T. Then we are going back to gate 2 and then back to the fern gully of F. So we are literally just listing our vertices. If we move on and look at a trail is a walk with no repeated edges. So again, if we look at this one here, if we've got no repeated edges, we can still have its repeated vertices. So as you'll see, when we're traveling, we're starting at G1. We are then going to B. We are then traveling to G2. We are then traveling to T, traveling to waterfall at W, traveling to the bridge, so we've already had that, and then we're going up to the fern gully, and we're going back to gate 2. So we can see here that we haven't gone over the same edge, but we have gone over a vertex more than once, and that is allowed. Okay, let's look at this question here. If you like, pause this video and have a go at solving it yourself. Which of the following represents a trail in the graph? So we've got I. I'll give you, so please pause and then we'll have a go. Okay, hopefully you have tried this question yourself. So the first thing I like to think about is trying to get rid of something that we can easily cancel out. And one thing we know about a trail is there's no repeated edges. One thing we can see with E to K, K to L, and L to K is that there will be a repeated edge. So E to K, K to L, and then L to K. It has got a repeated edge, which means it is not a trail. So we can cancel that out. Let's look at another one. Let's look at the first one. We've got S to L, L to K, K to M, and now we've got M back to K. Again, it is going over the same edge. And we can see that because we've got K, M, K. So it's showing us it's going back over it. Likewise, we've got K, L, K. So that is an easy way of us telling when it's going over the same edge. Let's go back and just double check if our last answer is a trail, which means it's got no repeated edges. So we've got G to K. Then I've got K to L. I've got L to S, S to E, E to K, and K to M. So here, it goes through a vertice that is common more than once, but it does not go through any edges that's the same. Okay, let's look at a path. A path is a walk with no repeated vertices. So as we can see over here, we are starting at G1. We are then traveling to F, traveling to B, traveling to waterfall of W, traveling to T, and then we go to gate 2 and exit. So there is no repeated vertices. It's a path through your maze, through your shape. Now, one thing I would like you to think about here, if we don't have any vertices that is the same, it also means that you can't have any edges that's the same. So now let's look at our question over here. It says, which of the following represents a path in the graph? So straight away, we can have a go at looking at them quickly. So we start off at K and go to E. Then we go to E to G, G to M, and M to L. So here I can see that it is a walk and we haven't repeated any vertices. Let's double check with the others. So we've got E, we're starting off at elephants. We are going to K. Then we got K to L, and we've got L to M. Again, that is a path because it's got no repeated vertices. Likewise, we've got K to S, S to E, E to K. Straight away, it's got a repeated vertex right here. So even if I continue, I know it's not a path. So this is where, here there is two answers. So we've got KEGML is one path, and the other path is EKLM. Now, we could tell without looking at this purely because there's two K's in our third walk, which means it is going through the same vertex. A circuit is exactly what the name describes. It's no repeated edges, but it starts and ends at the same point, so it must have the same vertex at the start and finish. So let's have a look at this question right here. So this here says we are starting at gate 1. We are then going to the Fern Gully, F. We are going down to B, the bridge, going to the waterfall, going to the old tree, back up to gate 2, back to the bridge, and to gate 1. So we finished on gate 1 and we started on gate 1. Now we haven't gone over the same edge. So even though we've got B and B, that's a vertex, so we can go through the same vertex, we just can't have the same edges for a circuit. Okay, let's have a look at our question over here. Again, please pause so you can have a go yourself. Okay, so this question says, which of the following represents a circuit in the graph? So I'm starting off at K and I'm finishing at K. I'm starting off at E and I'm finishing at E. So all of these have the same start and finish points. Now I'm just going to test it out. K to E, E to G, G to M, M to K, K to L, and then it says L to K. That shows me we're going back over that same point. Because we looked at, remember, if we've got KLK, that tells us it is going to be going back over the same edge. So we know our answer, we know our circuit is not the first one. Let's look at III. Again, I can see it's got KGK, so I know it can't be the circuit, but we'll test it out anyway. It says we're starting at K, going to S, going to elephants at E, going up to K, going to G, and then going back to K. Again, it's going over the same edge. So our answer must be our second. But let's double check that, because in the end, it's always better to double check just in case. So we are starting off at E and going to S and then going to K. From K we are going to L, L to M, M to K, and K to E. So we start it and finish at E, and we haven't gone over the same edge more than once. Okay, so let's have a look now at a cycle. A cycle is a walk that has no repeated vertices and starts and ends at the same vertex. So again, if there's no repeated vertices, except the last one, it means we can't have any repeated edges as well. So let's have a look at this first one. So here we are starting off at gate 2. We are then moving to the bridge. We are then moving to the waterfall, over to the tree, and back to gate 2. So we can see here that we are not going over the same vertice, except the vertex at the very start and end is the exact same. So that means we can look here and see that we should be having only those two at the start and finish the same. Let's double check with and find out which one of these graphs is a cycle. So we're supposed to start at K and then go to E. E to G and G to K. So that is starting and finishing at the same vertex, and it's got no repeated its vertices and no repeated edges. Okay, let's look at the second one. So we've got one answer. The second one says we're starting at G. We're going to K. K to M. M to L. L to K. So we're going through the same vertex here, which means it can't be. And we should have seen that because we've got a double of K in the middle. So we know it can't be this one. Let's look at our last one. We've got L to S, S to E, E to K, and K to L. So we found that we have two cycles here, and they are not going through the same vertex, except it has the same starting and end point. Hopefully this helps you understand the terms walks, trails, paths, circuits, and cycles.